And welcome back to another video of IGCSE chemistry, where we will learn about every chapter in the chemistry syllabus of IGCSE. In the last video, I finished explaining what filtration is, centrifuging and decanting, as well as simple distillation. That is part one of the topic of purification and separating mixtures. To follow this up, I will explain what fractional distillation is. While simple distillation will help us separate a solute from a solution, or you can say to separate a distillate from a solution, fractional distillation is when the mixture is made out of two liquids with very different boiling points. So, fractional distillation. How is it different from simple distillation? Well, first of all, the name, fractional. The word fractional comes from the fact that a piece of apparatus called a fractioning column that looks something like this is used. And at the bottom, it is connected to a round bottom flask, just like the simple distillation setup, where it is also heated, usually by a Bunsen burner. At the top of the fractioning column, it is also connected to a condenser, just like simple distillation. And just like simple distillation, a beaker or a flask or anything to collect the liquid that comes out of the condenser is set up at the end to collect whatever is dropped out. And just like simple distillation, the water will be entering from here, and the water will be coming out from here. And cold water is used specifically, as I have explained in the previous video. But what is so different about fractional distillation from simple distillation? Well, first of all, where simple distillation it is used to separate a volatile liquid from a solution, which is from, or a better word would be from a solution with a non-volatile solid, which basically means, well, it doesn't evaporate easily, or it doesn't boil easily, while the liquid does. Fractional distillation, however, is quite different. Fractional distillation separates a volatile liquid from a solution with a volatile liquid. However, these two liquids have to be miscible. I will give the example of this. This is water and oil. Just an example. These two liquids, they do not mix. That means if you put them in a flask, they will appear like this, while this is water. This may be oil, and this is water. This means it is not miscible. They are not miscible. A miscible example or a miscible solution made out of two miscible liquids means that it will form, visually, it will seem like it's one liquid. That is simply what it means. However, for this process to work, the two liquids must have different boiling points. Let's say water and alcohol, right? Water and alcohol. Water's boiling point is at 100 degrees Celsius, while ethanol or any other alcohol is lower than that, right? So when I heat up the solution in the round bottom flask over here, the ethanol or whatever alcohol will evaporate first, and when it is evaporated, it travels up. It travels upwards, up this fractioning column. The reason the fractioning column is very important is because, as you know, evaporation occurs at all temperatures. So when we heat up the solution, it is very possible, it will even be possible, it will even be very probable that, let's say, the example of water and ethanol, water will be evaporated as well. However, to prevent that from mixing in with the distillate, which we intend for it to be ethanol, we have these fractioning beads. Fractional beads. So basically, these fractioning beads stop the water from traveling too high up, while they allow the ethanol vapors to continue on in the condenser and be collected here in the flask at the end. The next method of separation I would like to explain is evaporation. Evaporation is a very simple method of separation that plays a very important role in another method of separation that I will explain later on. Evaporation is, as the name says, evaporation. The process works by putting a solution on anything. It can be a petri dish or it can be a plate, whatever. But this water or whatever liquid that's inside is a solution. Let's say salt water. The salt is the solute and water is the solvent, and therefore it is a solution. And how do we separate the salt from the water? This is where crystallization plays a big role. If we say we want to get the salt from salt water, we would say crystallization is the method to deal with this separation, right? And how does evaporation fit into this? The first thing we will do is to heat up the cubicle or the petri dish that contains this salt water, right? To a point where, at this point, at a temperature point, we will call that the crystallization point. At the crystallization point, at the surface of the solution, there will be small salt particles, or I should say, small salt crystals appearing at the surface of the solution. This heating up, I will call step 1, and the second part, which is after crystallization point, you will let it cool. When we let it cool, that means we take it off the heat and we just let it sit there. What this does is it evaporates the liquid. It evaporates the remaining, or I should say excess liquid. What this does is it only leaves the crystals behind. Step 3. The crystals are finally formed, and you will take them out very gently because they are very fragile, and to wash them with distilled water. Very little distilled water to make sure all the impurities are removed from the crystals, to make sure they are very pure sample of salt crystals. After washing them with distilled water, the fourth step is to clean them with filter paper, to gently press them in between two filter paper for it to dry, or to just leave it out to dry. And that's how you obtain pure sample of crystals of salt from salt water. There can be many other examples of this which are more complex. For example, potassium chloride from and potassium sulfate, where we will separate the potassium from the solution, where potassium is the solute, right? And the chloride is the solvent. So we will be making salt crystals, potassium salt crystals, or potassium crystals from potassium chloride. That is it for the second part of methods of purification and separation. I will be explaining another important part of separation, which is chromatography, which is the last part of this chapter, which I will explain in the next video. But until then, thank you for watching, and I hope to see you in the next video.